This is a black hole. I'm sure you've seen it before, or at least you think you have. But what you haven't seen is the terrifying truth that lies beyond its surface. Because everything you think you know might just be wrong or incomplete. In this video, we're diving headfirst into the 11 most burning questions about black holes. Mysteries so extreme, they challenge the very fabric of reality. From time travel to the edge of the universe to what might exist on the other side. Get ready to question everything. I am Jay, and you're watching Astrosium. Let's get to our topic. Black holes aren't just cosmic vacuum cleaners, as some might imagine. They are nature's greatest paradoxes. So dense, so extreme, they warp space, twist time, and shatter the laws of physics. So, buckle up. Let's dive into the first burning question. How can we learn about black holes if they trap light and can't actually be seen? If black holes are truly black, if they trap all light, then how can we possibly learn about them, let alone see them? This is where the universe gets clever. While the black hole itself is invisible, the evidence it leaves behind is not. Scientists observe the superheated gas and dust that spirals into a black hole, forming what's called an accretion disk. This material gets so hot, it emits powerful X-rays and other radiation, creating a luminous beacon that reveals the black hole's presence. Think of it like seeing the steam rising from a boiling pot, even if you can't see the heat itself. Furthermore, the black hole's immense gravity bends light from distant stars and galaxies, creating distorted, ghostly images, a phenomenon known as gravitational lensing. It's like looking through a cosmic funhouse mirror, and these distortions provide crucial clues about the black hole's mass and location. Do they really exist? And what's the best evidence? For centuries, black holes were just mathematical curiosities, theoretical constructs. But do they really exist? And what's the best evidence? The answer is a resounding yes. We've moved beyond theory to direct observation. One of the earliest pieces of evidence came from observing binary star systems, where a visible star orbits an unseen, massive companion. Too massive to be a normal star or neutron star. Then came the groundbreaking detection of gravitational waves. These ripples in space-time, predicted by Einstein, are generated when massive objects like black holes collide and merge, sending cosmic tremors across the universe. And perhaps most compellingly, in 2019, the Event Horizon Telescope gave us the first ever direct image of a black hole, the supermassive behemoth at the heart of galaxy M87. It wasn't a black circle on a black background, but a fiery ring of light, the glowing accretion disk silhouetting the black hole's shadow. This wasn't just a picture, it was proof. We're just scratching the surface of these cosmic mysteries. If you're finding this journey as fascinating as we are, make sure to hit that like button and subscribe to our channel for more deep dives into the wonders of the universe. Up next, we'll explore the surprising variety of black holes and answer the chilling question: what would really happen if you fell into one? Don't go anywhere. How big can a black hole get? How small can a black hole be? Stellar black holes are relatively small, perhaps only tens of kilometers across. Supermassive black holes, however, can be larger than our entire solar system. There's no theoretical upper limit to their size. They can continue to grow by accreting matter and merging with other black holes. What would happen if you fell into a black hole? This is perhaps one of the most chilling and fascinating questions. What would really happen if you fell into a black hole? The answer depends on the black hole's size. If you plunged into a stellar mass black hole, the immense difference in gravitational pull between your head and your feet would stretch you vertically and compress you horizontally, a gruesome process scientists dramatically call spaghettification. You'd be stretched into a long, thin noodle before reaching the singularity. However, for a supermassive black hole, the tidal forces at the event horizon are much weaker. You might cross the event horizon without immediate discomfort, experiencing nothing unusual. But don't get too comfortable. Once inside, all paths lead inevitably towards the singularity, and your ultimate fate remains the same: a journey to oblivion. What if the sun turned into a black hole? First, rest assured, it won't. Our sun simply isn't massive enough to ever become a black hole. It will eventually evolve into a white dwarf. But for the sake of argument, if our sun were to instantly transform into a black hole with the exact same mass it has today, something surprising would happen. Absolutely nothing to Earth's orbit. Its gravitational influence on our solar system would remain precisely the same. We wouldn't get sucked in. The only catastrophic change would be the immediate loss of sunlight, plunging Earth into an eternal, frozen darkness, a far more immediate threat than being swallowed. Is it possible for a black hole to eat an entire galaxy? Another pervasive myth is that black holes are cosmic vacuum cleaners, indiscriminately devouring everything in their path. So, is it possible for a black hole to eat an entire galaxy? Thankfully, no. While supermassive black holes reside at the heart of most galaxies, their gravitational reach, though immense, is localized. They only pull in objects that venture too close, much like any other massive object. Galaxies are vast, mostly empty spaces, and stars orbit their galactic centers at safe distances. A black hole might occasionally consume a rogue star or a cloud of gas that strays into its immediate vicinity, but it cannot devour an entire galaxy. The universe is safe from such a cosmic feast. Have black holes had any influence on our planet? You might wonder, have black holes had any influence on our planet? In a profound, indirect way, yes. Stellar mass black holes are the remnants of massive stars that end their lives in spectacular supernova explosions. These supernovae are not just destructive. They are cosmic alchemists, forging and scattering heavy elements like carbon, oxygen, and iron throughout the universe. These are the very elements that make up planets, stars, and indeed, all life, including us. So, in a very real sense, the violent deaths of massive stars, which lead to black holes, have enriched the cosmos with the building blocks necessary for our existence. We are, quite literally, made of stardust, much of it processed through the fiery crucible of a supernova. Don't miss the final segment, where we unravel the deepest mysteries of black holes, including their bizarre effects on time and the ultimate fate of the universe. If you're captivated by these cosmic giants, hit that subscribe button and ring the notification bell so you don't miss our grand finale. Do black holes last forever? Or how do black holes die? Given their immense gravity, it's easy to assume black holes are eternal cosmic prisons. But do black holes last forever? Surprisingly, no. According to Stephen Hawking's groundbreaking theory of Hawking radiation, black holes aren't entirely black. They slowly leak particles and radiation over vast stretches of cosmic time. This process, incredibly slow for stellar mass black holes, means that over trillions upon trillions of years, black holes will eventually evaporate and disappear. The largest supermassive black holes will take an almost unimaginable amount of time to vanish, far longer than the current age of the universe. But eventually, even they will fade away. leaving behind only a faint whisper of their former selves. Can we see both sides of a black hole? If light can't escape, can we see both sides of a black hole? This question touches on the bizarre nature of space-time around these objects. You cannot see through a black hole as if it were a window. It's not a hole in the conventional sense, but a region of space-time so warped that it effectively blocks anything behind it. However, the black hole's immense gravity can bend light from distant objects around it, acting like a cosmic lens. This phenomenon, gravitational lensing, can create distorted or even multiple images of background galaxies or stars, making it seem as if you're seeing around the black hole, even though you're not seeing through it. Are black holes wormholes? Idea of wormholes, shortcuts through space-time, is a staple of science fiction. But are black holes wormholes? While both involve extreme space-time curvature, the answer is generally no. A black hole is a one-way trip to a singularity. A wormhole, theoretically, would be a traversable tunnel connecting two different points in space-time, or even two different universes. While some theoretical solutions to Einstein's equations suggest the possibility of wormholes, they would require exotic matter with negative energy to remain open and stable, something we haven't observed. So, while black holes are not wormholes, their study continues to push the boundaries of our understanding of space-time, hinting at possibilities that are stranger than fiction. Could black holes be gateways to other universes? And now, for our final, most mind-bending question. Could black holes be gateways to other universes? This is where science truly meets speculation. Some theoretical models, particularly those involving the concept of a multiverse, propose that the singularity at the heart of a black hole might not be an end, but a beginning. A point where new universes could be born, or where our universe connects to others. While there's no observational evidence to support this, it's a fascinating idea that challenges our perception of reality. It suggests that these cosmic behemoths, far from being mere destroyers, might be the ultimate architects of creation, constantly recycling matter and energy into new cosmic possibilities. The universe, it seems, always has more secrets to reveal. From their mysterious birth to their potential role in the fabric of the multiverse, black holes continue to challenge and inspire us. They are a testament to the incredible, often counterintuitive, nature of our cosmos. I hope this journey has deepened your appreciation for these unseen architects of the universe. If you enjoyed this deep dive into black holes, please like this video, share it with your fellow cosmic explorers, and subscribe to our channel for more fascinating journeys through the universe.